All right, so let's take a look at question 19 from the 2024 Standard 2 paper. So we're told a teacher was exploring the relationship between marks on an assignment and their marks for a test. The data for 5 different students is shown. What is the equation of the least squares regression line for this data? Well, we just need to find the slope and the y-intercept. So for part A, the y-intercept of this line is 6. So the b value is equal to 6 because we can see it on the graph. That's where it intersects the test marks line. The slope is a little harder, but we can see 2 clear points that this cuts. One is right at the beginning, where we have the coordinates 0, 6. The other one is right at the end. It has the coordinates 10, 20. 10, 20. So if we draw a little slope triangle, if we go from 0 to 10, the base must be 10. If we go from 6 to 20, the height must be 14. So the slope, which is the rise, which is 14, over the run, which is 10, comes out to be 1.4. So our line of best fit, lob, is in the form y equals 1.4 times x plus 6. And this is the equation that we want for part A. Now for part B, another student whose marks are on the graph scored 5 on the assignment and 12 on the test. Did the student do better or worse on the test than the regression line predicts? Well, the progression line predicts that if you got a 5 on the assignment, you carry it up. So we can let x equal 5. We find that the predicted test mark is 1.4 times 5 plus 6. 1.4 times 5 is 7. 7 plus 6 is 13. So the predicted mark is 13. The student actually got 12. So the student did worse than expected because their mark was lower than the mark forecast from the line. We should note that this student is not listed in the data set, in the actual data to begin with. This is an extra student. So they did worse, and this is the reasoning. So this is question 19.